Hello children, this is Roshni from Learner Hub, the free learning platform, and welcome to the second video of the video series on light, reflection and refraction class 10th science. In this video, we are going to learn about image formation by concave and convex mirrors and also application of spherical mirrors. So are we all ready? Let's get started. So now we will look at image formation by spherical mirrors. How do spherical mirrors form images of different objects placed at different locations? Now there are a few important things we will talk about before we start with the topic. First thing is, now where exactly is the image formed, or what is the concept of formation of image in case of a spherical mirror? The rays originating from a point actually meet at another point after reflection. So the point at which the rays meet after reflection is the point where the image is formed. So that means as we go ahead, you will see that irrespective of wherever the object is located, the image will always be formed at the point where the reflected rays will meet after reflection, right? So that is the first point. Now, there are two different things now. There is one possibility that the rays will actually meet after reflection, as you have seen in case of concave mirror. In concave mirror, what happened? The incident rays after reflection, they actually converged through the principal focus. So if the rays actually meet, then a real image is formed because the rays are meeting really, right? Now, there is another possibility that the rays do not meet actually, but they appear to meet. So in that case, a virtual image is formed. So there are two types of image that can be formed by a spherical mirror. One is a real image and the other one is a virtual image. In case of real image, the reflected rays will actually meet at a point. In case of virtual image, the rays will appear to meet at a point. So now if you look at these different kinds of mirrors. So first I have taken a plane mirror. So in plane mirror, what happens? The image which you get is a virtual image, but it is the same, identical to the object, and it is of the same size as that of the object. Now you take the example of a convex mirror. In convex mirror, what do you get? We again get a virtual image. In case of concave mirror, you get both virtual image as well as real image. Here if you see, you have got a virtual image, but here again with the same concave mirror, you got a real image. This was your object and this was the image. So that means in concave mirror, depending upon the position of the object, how far is the object located from the mirror, depending on that you get, it depends on that whether you will get a virtual image or a real image, right? So these are the two types of images that can be formed, and the concept is that the point at which the reflected rays will meet is the point where the image will be formed. So with this concept in mind, let us go through the rules for image formation by spherical mirrors. There are a set of rules which are to be followed to find out to understand the image formation by spherical mirrors. So here is the rule number 1. It says that whenever a ray of light is incident on the mirror parallel to the principal axis, it passes through the principal focus after reflection. That means this is a concave mirror. Let us suppose if you have a ray of light which is incident on the mirror and which is parallel to the principal axis. So this is your principal axis, right? So it is parallel to the principal axis. So after reflection, the ray will pass through the principal focus. So here this is your incident ray and this is your reflected ray. So this is your first rule. So what will happen in case of a convex mirror? In convex mirror, suppose this is the ray of light which is incident parallel to the principal axis. Now after reflection, what will happen? As it strikes the mirror, this ray will have a tendency to move like this, that is, it will diverge. But if you extrapolate it, it will appear as if it is passing through the principal focus. So in this case, this is your incident ray and this is your reflected ray. Because convex mirror is a diverging mirror. So in this case, whenever the rays of light strikes the mirror, it gets diverged. It gets bounced back. Because for any mirror, it will get bounced back, right? It will not cross the mirror and pass through it. So it will get bounced back and it will get diverged. So if you extrapolate it, it will appear to pass through this principal focus, right? Rule number 2. A ray of light which passes through the principal focus towards the spherical mirror after reflection is reflected parallel to the principal axis. So it is just the opposite of rule number 1. It says that if the incident ray of light passes through the principal focus and then it is incident on the mirror, then after reflection it will go parallel to the principal axis. So in this case, this is your incident ray and this is your reflected ray. So what will happen in case of a convex mirror? So in case of convex mirror again, if you have a ray of light which passes through principal focus, that means let us suppose if you have a ray of light like this, which appears to pass through the principal focus, after reflection, it will go parallel to the principal axis. Please remember that whenever you denote a ray of light, this arrow, do not forget to put this arrow, because this arrow indicates the direction of the ray of light, right? So this is how it will happen in case of a convex mirror. Let us look at rule number 3. It says that a ray of light which passes through the center of curvature of a spherical mirror after reflection retraces the same path, that is, goes back along the same path. So let us suppose if you have a ray of light which passes through the center of curvature. Let us suppose it passed through this point. So if this is your incident ray, then after reflection, after it strikes the mirror, it goes back along the same path, right? So similarly in this case also, let us suppose if there is a ray which falls on this mirror such that it appears to pass through this center of curvature, then after reflection it goes back along the same path. The last rule, that is rule number 4. A ray of light which is incident towards the pole of the spherical mirror obliquely to the principal axis is reflected obliquely. What is obliquely? Obliquely means making some acute angle. Let's suppose if you have an incident ray which falls towards the pole of the mirror obliquely to the principal axis, that means making some angle theta to the principal axis, then it gets reflected obliquely. That means the reflection will also happen obliquely with the principal axis. So this is how it will happen for concave mirror. Similarly, in case of convex mirror also the same thing will happen. If a ray of light falls towards the pole making some angle theta with the principal axis, it will go back in a similar manner. So this is your incident ray and this is your reflected ray. So these are the 4 rules. So once you are aware of these 4 rules and you are aware of the fact that image will be formed at the point where the reflected rays will meet, with the help of these 2 concepts, you will be able to plot the ray diagrams for objects located at different positions. Now this kind of diagram which we draw to represent the image formation by a mirror, where what do? We represent the rays of light, we draw the mirror showing its pole, focus and center of curvature. These diagrams are known as ray diagrams. Now we will first focus on the image formation by concave mirrors. So we will first talk only about the concave mirror. So let us take the first scenario where we assume that an object is placed at infinity. So how would be the ray diagram in case of object at infinity? So when the object is at infinity, that means the incident rays are coming from some distant point. So we assume that parallel rays of light are coming, right? Because the object is at a very far off distance, we don't know where. So let us suppose that there is one ray which is falling obliquely towards the pole. So what will happen? How will it get reflected? if this is my incident ray, how will it get reflected? It will get reflected obliquely, right? Now let us suppose there is another ray which is coming from the object such that it passes through the center of curvature. So this ray will meet the mirror somewhere here. Let us suppose this is my mirror. So after reflection, what will happen? It will go back along the same path, right? Now, what do we know? Where is an image formed? It is formed at a point where the reflected rays meet. So here, this is one reflected ray and this is another reflected ray. So both these rays meet at this point. So that means the image is formed at this point. So this is my image, right? So this is the image which is formed. So what kind of image is formed? We get a real image because in this case the reflected rays actually meet at this point. So what is the nature of the image? It is a real image. It is an inverted image. So if the image would have been formed like this, it would have been an erect image. But since it is formed the other way around, so it is an inverted image. So we got an real image, inverted image, and what is the location of the image? It is formed at the focal length. So that means when the object is at infinity in front of a concave mirror, a real and inverted image will be formed at the principal focus of the concave mirror, right? Okay, now let us look at the second scenario where we say that the object is beyond the center of curvature. That means the object is far from the mirror, but it is not that far. So that means it is somewhere beyond the center of curvature. So let us assume that the object is somewhere here. So let me denote this AB. Let me call the object as AB. This is some object. So now in this case, let us suppose there is a ray of light which goes parallel to the principal axis and falls on the mirror. So according to rule number 1, what will happen? A ray of light parallel to the principal axis after reflection passes through the principal focus. So this is how it will go after the reflection. Now let us suppose there is another ray which passes through the center of curvature. Suppose there is another ray which passes through the center of curvature and falls on the mirror. So what will happen to this ray? After reflection, it will retrace the same path. So what is the point? Which is the point where the two reflected rays are meeting? This is the point, so that means an image will be formed here. So we will call this image as B dash A dash. Now what is the nature of this image? This is real again because the rays are actually meeting at this point. It is inverted again, right? What is the location of the image? So if the object is located beyond the center of curvature, then the image is formed between the principal focus and the center of curvature. What about the size of the image? If you look at it, the size of the image is smaller than the size of the object. The length AB is greater than the length B dash A dash. So the image is diminished. That means it is smaller in size than the object. So this is the nature of the image formed when the object is placed in front of the concave mirror beyond its center of curvature. So I guess now you are understanding, you are getting an idea how do we plot a ray diagram, and these diagrams are known as ray diagrams because we are playing with the rays of light. So it is called ray diagrams. Let us look at the third case where we see that the object is placed at center of curvature. So if you see, we are gradually bringing the object closer to the concave mirror, right? Before it was, first it was at infinity, then it was beyond the center of curvature. Now it is at the center of curvature. So that means let us suppose this is my object. So let me call this object as AB. So here also, now it is not necessary that you have to assume the first ray to be parallel to the principal axis and then passing through the focus. You can consider any of those 4 rules which I mentioned. You can consider that the ray of light from this is passing through the principal focus and after reflection goes parallel to the principal axis. You can assume that it falls obliquely and then goes back, and you can take any of the 2 rules. Any out of those 4 rules, you can consider any 2 or any 3, and you will see that all the reflected rays will meet at a point, and at that point image will be formed, right? So now in this case, let us again suppose that there is one ray of light which is going parallel to the principal axis, and as per rule number 1, it passes through the principal focus. Now let us put the another rule here is rule number 2. That means the another ray is passing through the principal focus. So after reflection, it will go parallel to the principal axis. So what do we see? They meet at this point. That means an image will be formed here. And we call this image as B dash A dash. So what is the nature of this image? It is again real because the rays are actually meeting at this point. It is again inverted, right? What about the location? The location is center of curvature. That means if the object is located at the center of curvature, the image will also be formed at the center of curvature. And what about the size? If you look at it, the size of the object and the image are comparable. That means they are almost of the same size. So this describes the nature of the image formed when the object is at center of curvature. Let us look at the fourth scenario where we want the object to be placed between the center of curvature and the principal focus. So now the object is still nearer to the mirror. So this is my object AB. So here also let me assume any two rules. A ray of light parallel to principal axis after reflection passes through the principal focus, right? Another ray of light passes through principal focus and after reflection goes parallel to the principal axis. Well, in this case, the diagram is not plotted properly because in this case, the two rays of light will meet at a point which will be beyond the center of curvature. I mean, since here I am plotting the lines, I am not plotting it correctly with measuring scales, so it is not meeting at the exact point. Otherwise, this point should be such that it is beyond the center of curvature. So that means you have it B dash and A dash. So in this case, what kind of image do you get? It is again a real image, inverted image located beyond the center of curvature. And what about the size? In this case, the image is enlarged. If you see, the length of the image is greater than the length of the object. So you get an enlarged or magnified image now. Let us bring the object even more near to the mirror. So let us place the object at the principal focus. So now we have our object at F. So in this case again, ray of light parallel to the principal axis after reflection passes through the principal focus, right? Another ray of light, let us suppose it falls obliquely to the pole making some angle theta. So after reflection, it will go obliquely. So in this case, what do we see? The two rays are going almost parallel and they do not appear to meet immediately. So that means what do we assume? We assume that these two rays, since they are going parallel, so they will meet at some infinite point. So we say that the image is formed at infinity. So here the image at infinity, because the rays are going parallel. So here I have not drawn it correctly. So this line will go parallel to this line. So the image in this case is formed at infinity. And what kind of image will be formed? Real image, because doesn't matter how much ever far, but the rays will actually meet. So you will get a real image, and the image will also be inverted because it will meet somewhere here. That means it will meet somewhere below the principal axis, and so you will get an inverted image. And what would be the size? The size would be enlarged. That's because the farther away it meets, the greater becomes the size of the image, right? So it will be enlarged. Let us try to bring the object little more closer. So let us place the object between the pole and principal focus. So what happens in this case? A ray of light parallel passes through the principal focus. Another ray of light falls on the pole obliquely and then goes back. So in this case, what do we see? That the two rays don't go parallel. Instead, they diverge away from each other. So that means there is no possibility that they will meet up in future. If the two rays are going parallel, we assume that they will meet up at some infinite point. But if they are moving away from each other, there is no possibility that they will ever meet. So in this case, what do? We extrapolate it at the back and we see that they appear to meet at this point, and then we say that this is my image. So we say this A dash B dash is the image formed. So in this case, what is the nature of the image? It is virtual, because in this case the rays do not meet actually. The image is erect. What is the location of the image? In this case, the image is formed on the other side of mirror. Till now it was forming, the image was getting formed on the same side of the mirror. Now it is formed on the other side of the mirror. What about the size of the image? It is enlarged, right? So I hope you understood how we decide the image formation by a concave mirror. That means where will be an image formed, what would be the nature of that image, what would be the size of the image. All those things can be decided with the help of ray diagrams. So now this chart tells you, till now we have discussed all different object locations. So this chart is a review of whatever we have derived so far. So when the object is at infinity, the image is formed at the focus, nature is real and inverted, and the size is diminished. As the object is brought little closer, so here if you observe, you see that as the object is brought closer to the mirror, the image formed goes away from the mirror, right? See, the object is brought nearer from infinity to focus, and the image goes from focus to infinity. As the object is coming nearer, the image is going away. And as the object is coming nearer, the image is increasing in size, because when the object was at infinity, the image was diminished. Then gradually the image became of the same size, then it started becoming enlarged. So with this, we will end our discussion on concave mirror, and now we will look at the image formation by a convex mirror. So on similar lines, following the same rules and concept, we will look at the image formation by concave mirror. So we will first consider the case where the object is placed at infinity. So in case of a convex mirror, what will happen if the object is at infinity? That means parallel rays will be coming. Let us suppose we have one ray which falls obliquely to the pole, so it will get reflected obliquely. Let us suppose there is another ray which appears to pass through the center of curvature. So what will happen after reflection? It will retrace the same path. It will go back along the same path. So what do you see? Are these rays, which are the reflected rays? This is my reflected ray and this is my reflected ray. So do you think there is any possibility that these rays will meet up anywhere? No. But if we extrapolate it in the backward direction, they appear to meet at some point. So that means they appear to meet at some point if we extrapolate it. So in this case, what kind of image is formed? The image formed is virtual, erect and diminished. So that means in this case, a virtual image is formed. Whenever you get a virtual image, that image is always erect. So you get a virtual image, erect image, and it is formed at the focus. See, in these ray diagrams, since I am drawing it free-handed, so therefore the locations are not coming at the exact same point. But when you draw it properly with scales and all, you will find that the rays will meet exactly at those points. For example, here it did not meet exactly at focus, but it should meet exactly at focus. So here also the image will be formed at focus, right? And the size of the image is obviously diminished. Now let us look at the scenario where we say that the object is placed anywhere between pole and infinity. In case of convex mirror, we do not discuss about different positions, because since it is a diverging mirror, we do not get very distinct images at each point. I mean, here we only discuss two things. One is the object is at infinity and the object is anywhere between pole and infinity, because for any point between pole and infinity, the nature of the image remains almost the same. So let us try to plot it. Let us suppose the image is somewhere at this, the object is somewhere here. This AB is my object. Let us suppose there is one ray which falls obliquely on the pole, goes back obliquely. There is another ray which goes parallel to the principal axis. After reflection, it should virtually pass through the principal focus, but actually it gets diverged. So where will the refracted rays meet? This is one reflected ray, this is another reflected ray. So we will make them meet somewhere here. So here also, in this case also, we will get a virtual image, an erect image, a diminished image. So what happens in this case is that doesn't matter wherever the object is located, the image formed is always virtual, erect and diminished. So the nature of the image always remains the same, and the image will be formed somewhere between the pole and the focus. Let us look at some of the applications of spherical mirrors. I mean, where do we actually use spherical mirrors? There are very important applications of spherical mirrors in our day-to-day life. For example, if we talk about the first application being a shaving mirror, you would have seen that the shaving mirror which you normally see in shops, what are those mirrors? Those are the mirrors which are supposed to give enlarged image of your face, so that it becomes easier for the person to shave, because he can see an enlarged view of his face. So that means you want enlarged images. And just in the last slide, I showed you that if you use a convex mirror, you will always get diminished images. So that means you will have to use a concave mirror. So the shaving mirrors are always concave mirrors. Next is in torches. You will see in torch headlights. What kind of mirrors do you have? In torch headlight, what are the purpose of the torch headlights? To focus light on a small area. So that means whenever you want to focus light on something, you want that all the light rays which falls on the mirror should converge at a point. They should all focus at a point. So for that you will use a converging mirror, right? So which is a converging mirror? The concave mirror. So concave mirror is used in torch headlights. When we talk of the rear view mirrors in your vehicle, as I mentioned before also, just beside your driver's seat, you can see a small mirror which gives you a view of the traffic which is there behind. So what kind of mirror would you prefer here? You want a diminished image in this case, because let us suppose just behind your car there are some 3 to 4 vehicles. So you want to get a small view of all those 3 to 4 vehicles in that small mirror. That means you want that diminished images should be formed. So which mirror will give you diminished images? Convex mirror. Now you might say that in case of concave mirror also we got diminished images, but in that case we got diminished images only for certain object locations, right? Only when the object was located at infinity, or when the object was located far beyond the center of curvature, only then we got diminished images. But if the object was quite closer to the mirror, we got enlarged images. So we cannot use a concave mirror in this case, because while you are driving, it is not necessary that the vehicles which are there behind will always be very far off. So convex mirror is a better image, firstly because it gives diminished images. At the same time, it also gives virtual erect images. Rear view, it gives virtual and erect images. For rear view mirrors, convex mirror is a better choice. Next is the dentist mirror. You would have seen that when you visit a dentist, he uses a mirror to have an enlarged view of your teeth. So whenever you want enlarged view, you will go for concave mirror. Next is the vehicle headlights. Again, the vehicle headlights purpose is also the same. They want to focus light on specific area. So since the purpose is to focus light, that means they want to converge the light rays. So we will use the converging mirror, that is the concave mirror. Next one is the street light. You would have seen that you have some mirrors on your street lights as well. So what kind of mirrors do you want? What is the purpose of the street light? To spread the light over the street, right? So it wants to diverge the light. It wants to spread the light. It doesn't want to focus on a specific area, right? So for this we will use a diverging mirror, and diverging mirror is your convex mirror. So these are some of the important applications of the two types of spherical mirrors.
So children, how did you like this video? Did you find it useful? If yes, do not forget to share it with your friends so that they can also understand this lesson like never before. And I will meet you all very soon with a new topic, with a new video. Till then, take care. Bye-bye.